Have you ever analyzed whether we're truly alone in the universe? Of course, expecting that there's something else to our reality other than what we see. Imagine what would happen if the James Webb Telescope finally revealed that we live inside a black hole. Join us as we delve into the significant news that will make you question everything you thought you understood about the universe. So, what exactly are black holes? They're like something out of a terrifying dream. Sure, you might have seen them in science fiction movies, but they're far more surprising in reality. According to experts, black holes in space are enormous amounts of matter compressed into an incredibly small region. Imagine a star much larger than the sun packed into a sphere the size of New York City. The gravitational pull is so strong that nothing, not even light, can escape from it. Scientists have been fascinated by black holes for a long time. They've studied objects in space so massive and dense that they could trap light. The most famous theories about black holes were predicted by Einstein's theory of general relativity. Essentially, when a massive star dies, it leaves behind a dense core. If this core's mass is more than that of the sun, gravity overwhelms everything, leading to the creation of a black hole. Detecting black holes is no simple task since they emit no light. However, scientists have found ways to detect their presence by observing their effects on nearby matter. For instance, if a black hole passes through interstellar matter, it will pull that matter toward it in a process called accretion. Additionally, when a star gets too close to a black hole, it can be torn apart, emitting X-rays as it does so. Black holes also have a huge impact on their surroundings. They can consume nearby stars, emit powerful energy, and even influence the formation of new stars in some regions, while slowing it down in others. But where do black holes come from? Imagine stars, once massive, meeting their ultimate end in a catastrophic event called a supernova. From the remnants of these fallen giants, black holes are born. Most black holes form from massive stars that have reached their stellar retirement. Smaller stars, when they die, become neutron stars, extremely dense but not dense enough to trap light. However, if a star is several times the mass of our sun, it collapses under its gravitational force, forming a black hole. As these collapses occur, something strange happens near their surfaces. Time itself starts to behave differently. From the perspective of someone far away, time seems to slow down near the event horizon, the point of no return for anything falling into a black hole. It's as if the star's clock ticks at a different speed compared to ours. Sometimes, when two smaller black holes collide, they merge to form a much larger, even more terrifying black hole. If a black hole interacts with a neutron star, it creates a monstrous phenomenon that challenges observation. Scientists have been wrestling with the size and nature of these mysterious entities for decades. Black holes come in various sizes, small and large. There's an eerie mystery surrounding them that we haven't fully unraveled. However, small is a relative term when it comes to black holes. Stellar mass black holes, the remnants of massive stars, can be 10 to several dozen times the mass of the sun. There could be as many as 10 million to a billion of them in our Milky Way alone, an astronomical number of black holes that could swallow anything in their path. But wait, there's something even more massive. Supermassive black holes lie at the other extreme. They are millions, if not billions, of times larger than the sun and exist at the centers of giant galaxies, including our Milky Way. These black holes are like gigantic, dark voids pulling everything toward them. Renowned physicist Stephen Hawking studied black holes throughout his life. His lectures were always insightful, though some of his theories remained unconfirmed due to the lack of necessary equipment. But there's hope. A single scientific instrument is making a huge impact. The James Webb Space Telescope, JWST. The JWST is no ordinary telescope. It's an engineering marvel, a testament to human ambition. Sure, we've launched other space telescopes, but this one is truly extraordinary. The JWST makes the Hubble, which served us faithfully for decades, look like a mere speck in the universe. Its staggering $10 billion cost reflects its importance, made possible by NASA, the European Space Agency, and the Canadian Space Agency, with contributions from over 300 universities. However, such an ambitious project isn't without risks. The JWST is venturing into unknown territory, pushing the boundaries of what we know. Since its launch, it has achieved remarkable feats. It traveled over 1 million miles to reach its orbit around the Sun, where it will remain. Along the way, it successfully deployed its massive 5-layer sunshield and giant primary mirror, both of which had to be folded to fit into the launch vehicle. One of the most fascinating moments was when NASA announced the JWST had captured its first images of starlight. The first image taken was of a star called HD 8446, resulting in a mosaic of 18 scattered bright spots. NASA later released another stunning image, where these 18 unfocused copies were combined into a precise hexagonal arrangement. Once aligned, the JWST began merging these images into a clear view. Thanks to its cutting-edge technology, the JWST will help researchers study the early stages of the universe after the Big Bang. It will focus on what happened after the first stars formed, a period known as the Epoch of Reionization. The telescope will also help identify exoplanets and analyze their atmospheres, potentially determining their habitability. Most importantly, the JWST aims to answer fundamental questions. Are we alone in the universe? Are we living inside a black hole? Recent observations have revealed intriguing findings. The JWST detected polycyclic aromatic hydrocarbons, PAHs, near supermassive black holes in 3 active galaxies. These carbon-based molecules, often considered building blocks of life, glow under ultraviolet radiation. The findings suggest something even more profound about our existence, hinting at the possibility that we may indeed live within a cosmic enigma, a black hole itself. The implications of this discovery are profound. If we consider the hypothesis that our universe might exist inside a black hole, it opens a Pandora's box of questions about reality, existence, and the very nature of our cosmos. Imagine our universe as a bubble inside a black hole's event horizon, with the laws of physics we know being just a small subset of a much larger, more complex reality. This concept challenges everything we think we know about space, time, and gravity. Some theoretical physicists suggest that black holes might be gateways to other universes. According to this idea, every black hole could contain a universe within it, and our universe could be the interior of a black hole that exists within another parent universe. This aligns with the concept of a multiverse, a collection of multiple, perhaps infinite, universes, each governed by its own set of physical laws. The JWST's mission is to peer back in time to the earliest stages of the universe, but its findings might help us understand not only where we came from, but also the fundamental structure of reality. If black holes are indeed connected to other universes, or if we are inside one, it could explain some of the biggest mysteries in cosmology, such as dark matter and dark energy. These invisible forces make up most of the universe's mass and energy, yet we still don't fully understand what they are or where they come from. The role of the James Webb Space Telescope. The JWST is already rewriting our understanding of the cosmos. By observing distant galaxies, stars, and black holes, it is gathering data that may one day confirm or refute these extraordinary theories. Its powerful instruments allow it to detect infrared light from the farthest reaches of space, effectively looking billions of years into the past. This capability might help scientists identify the first stars and galaxies that formed after the Big Bang and understand the processes that led to the universe's current structure. In addition to studying black holes, the JWST is also exploring exoplanets, planets outside our solar system. Its advanced sensors can analyze the atmospheres of these distant worlds, searching for signs of life. This research brings us closer to answering one of humanity's oldest questions. Are we alone in the universe? The discovery of life on another planet, even in the form of simple microorganisms, would have profound implications for our understanding of our place in the cosmos. The future of black hole research. As we continue to explore the universe, our understanding of black holes will undoubtedly deepen. Future missions and technologies, building on the foundation laid by the JWST, will provide even more detailed observations. Projects like the Event Horizon Telescope, which captured the first image of a black hole in 2019, are already expanding our knowledge. Combined with JWST's capabilities, we are entering a golden age of space exploration and discovery, a cosmic perspective. The idea that we might be living inside a black hole is both humbling and awe-inspiring. It forces us to consider the vastness of the universe and the limits of human knowledge. If this hypothesis proves true, it would mean that everything we experience, space, time, matter, exists within a much larger, more complex reality. Our universe might be just one of many, each with its own laws and dimensions. This perspective doesn't diminish our significance. Instead, it highlights the incredible journey of discovery that lies ahead. As the JWST continues to unveil the secrets of the cosmos, we are reminded of the boundless curiosity and ingenuity that drive human exploration. The universe is full of mysteries, and each new discovery brings us one step closer to understanding our place in the grand cosmic tapestry. So, as we gaze at the stars and marvel at the wonders of space, we are not just looking outward. We are also looking inward, searching for answers about our origins, our destiny, and the true nature of reality. The journey has just begun, and the possibilities are as limitless as the universe itself.